Hello viewers, Alan here, welcome back to the workshop. So job at hand today is to mount a milling slide onto the cross slide of a lathe. It's a job I'm doing for a mate. He has at the moment a milling slide that fits on in place of the top slide, but he's not happy with it for several reasons, and one of them, which we're particularly going to address today, is that by mounting it here it doesn't work very well with the cross slide travel. To get the milling vise, so the milling slide lined up with a lathe spindle, he has the cross slide moved pretty much all the way across, which really restricts what's possible. So, and also he doesn't like the existing milling slide because of the quality of it. So we've rounded up this beast, which is actually a genuine Myford milling slide, meant for a Myford lathe. And my mate's lathe is a little bit bigger than that, so we have to lift this up as well as deal with this issue of positioning it correctly in front of the spindle. So the plan is to make a plate which can fit on directly onto the cross slide and then bolt this to that. We've been through several iterations working out the best option, and the one was certainly to have a square plate. Problem with that is it doesn't allow this to rotate as it can otherwise do. So Mark II of the design is a plate with rounded corners that basically matches the base of the slide, so that this will be removed in use, so you have good rotation. So that's the job, is to this has been prototyped with a 3D printer, and so the job is to make it in steel. I've got a plate on the front here. I've got to try to stop saying I say a lot. I've tried to stop. So this will have a plate on the front. The purpose of that is so that there'll be a little bit of wiggle room with the bolt pattern holding this to the cross slide. So the idea is to use that to correctly align the base. And even though this thing rotates, the reason for doing that is that the base actually has an index mark on the back, and it would be nice that when this goes on every time to know that the orientation is preserved. Well, that's enough waffle. Let's start cutting some metal. So putting a coolant system on this bandsaw was one of the best things I've done. The blades last a lot longer and it keeps the chips cleared out of the cut. So the last time I cut some 12mm plate, I used my Metabo electric cold saw thing. It did a pretty reasonable job, but it was a bit of a struggle. I think 12mm was asking a lot of it. This bandsaw though just cruises through that, as you saw. It's just designed for that sort of work. So I've started cleaning these edges up in preparation to bringing these plates to size, and I thought, having done a clean-up pass on both sides, I'd check the dimension to make sure I'm square before I get closer to true size. So up this end we're half a hair under 88.9. The other end, I should say that's pretty much the same. Close enough for me anyway. So that check tells me these two edges are parallel. I can put this thing back in the milling vise and bring this dimension to size. The finished dimension that I'm looking for is 85, so I've got just under 4mm to take off. I'll take that in 1mm deep swipes. This cutter seems to work quite well like that. And so on until we get to size. So I've set for a 0.5mm depth of cut, which should be my final pass. Fingers crossed. So we've finished up 0.03 oversize over the nominal size, but at least it's square. That's going to be good enough. So time to move on to the other pair of edges. So I've got my two pieces cut to size and the edges machined neatly. Now I want to do the two faces, or the four faces I suppose, using this fly cutter. This guy's got quite a heavy body, so it gives a pretty good finish. I'm running it at 600 RPM and taking a 0.1 thick or 0.1 deep cut to get rid of all this mill scale. So I think they're cleaned up pretty nicely for a bit of hot rolled steel. Well, I don't think there's anything to complain about with that surface finish. You're getting diffraction patterns off that. So the other three faces to do. To round these corners off, I need some way of mounting these plates so that I can rotate them either in the lathe or on the milling machine. To do that, I'm going to make up an arbor. The scrap bin has provided 33mm diameter bar and the flange from an old water pump, if I remember correctly. I've already chopped a lump off that bar, cleaned it up and machined the back face to 25.4. Before now machining back here to create a reference surface or to create a spigot that this will press onto, I wanted to check the concentricity, because turning things around in a three-jaw chuck always has the chance of introducing problems. In this case I've done quite well, I think. I've got a 0.03 run out, which is pretty good. The bore of this flange measures 29.71, so my plan is to machine a spigot with a diameter of 29.73, so it should be quite a firm press fit on here. Once I have this mounted on there, I'll drill the bolt pattern to match the plates that I'm making. I'm going to start with a cut that will take about 1.5mm off the diameter and bring the OD down to 31, check the DRO calibration and take it from there. So shooting for 31. It's actually pretty close. I'll make 30 the next target and then sneak up on the final diameter. Okay, shooting for 29.73. Fingers crossed. Happy with that. Yes, that's going to press on there nicely. So while I was inside getting lunch, physics decided to do me a favour, and the workpiece cooled slightly and I exactly hit the mark. Let's see if we can get this pressed in. Make sure everything's square. Okay. So I don't think that's going to fall off. That went on with just the right amount of force to give me comfort. So now I can machine this face off, including that boss, because I don't need it. I think this is cast iron, so I've put a rag down to collect as much of the dust as I can. So I'll just face this off now, and that certainly is cast iron. So I'll take a pass with a 0.1 depth of cut across the face. So that cleaned up nicely. I will give it a skim on the OD because that may be helpful when it comes to setting it up on the milling machine for the bolt pattern. I think I'll put a centre in it as well. That looks fine. I don't think I need to do anything with those corners either. So I'll just put a centre in. Right, that's finished that, so over to the mill. So I mounted this thing in a 3-jaw chuck on the rotary table, and using my 3 jack screws, it was very easy to quickly get this to being very close to centred, certainly close enough. So that's actually pretty darn good. I was seeing only about a 1.01 or 0.02 run out. Amazing. Anyway, that's now centred on the rotary table. To get this centred under the quill, I'll start off with an edge finder that has a pointy bit. Lower that into the hole and use fingers to feel, and you get pretty close. Then I'll swap this out for a dial gauge to sweep around the outside. So using this and sense of touch gave me a very good start, and it was quite easy to make a couple of minor adjustments. You can't see it, but as I sweep that all the way around now, we're on 0 or pretty close to it. That's certainly going to be good enough for rounding some corners and putting a chamfer on. I have to drill a 4-hole pattern into this plate to match the holes in the mounting for the milling machine that I'm making up, milling slide. I'd like these new holes to be centred on the existing pattern, and I think the easiest way to do that is to sweep across, establish a diameter, and then I can rotate 45 degrees and get what I want. I think I'm pretty much there. And I think that'll be good enough. Set up for drilling now, and the 4 holes that I want to put in this plate, the centres would sit on the corners of a square 54mm by 54. Maths tells me that's a pitch circle diameter of 76.37. I'm going to use the hole pattern feature of the DRO to put those 4 holes in, because I think it's actually easier and possibly more accurate than doing 90-degree rotations of the rotary table. So that should be 4 holes in the correct place. I just need to tap them now for an M8 thread. And lucky last. Whether something moved at the last minute there, or my eyes deceived me. Anyway, let's find out whether the plate will fit on. Right, moment of truth. Oh, that's 1 in a row. 2 in a row. 3. 4. Excellent. It's also loose on the bolt pattern, which is a very good sign. It means it's centered correctly. Very happy about that. I'll tell you something else too. It's very difficult to do these little videos, remembering not to say and I've put the plate on the jig or fixture now, and it can move on the free play in the bolt pattern. To centre it as best as I can, I did put a centre in, and I have mounted in a collet a small one of these guys, which has a 60-degree point, blind point on the end. With that pressing into the divot there, I then did all the bolts up tight. So I'm pretty confident that the plate is centred on its bolt pattern. Getting ready now to mill off these corners with a big radius. That doesn't feel very good. I've reset my first cutting radius from 64 to 66 millimeters. See if it's any happier with that. Well, that seems to be working okay. I'll take the additional 2 cuts to 12 millimeters depth and then move in a bit. Well, that sort of worked, but I wasn't very comfortable with it, so I swapped the cutter out. I don't have a 4-tooth or 4-lipped cutter. This is 3, but the other one was 2. We'll see if 3 does a better job. The previous cut was on a diameter of 66. We'll go on 64 this time. So I suppose that's nominally a 1 millimeter depth of cut. We'll see how that goes. Well, that sounded a lot happier. So we'll press on with that. So after a bit of experimentation, I was getting good results with reducing the diameter 2 millimeters a shot, and I increased the depth of cut to 6. So I'm going around twice. This is the final pass now. Well, I'm quite happy with the way that turned out. So I've drilled the hole pattern. Now it's time for some of the more interesting bits. I have to tap the 2 middle holes here to M8. So it helps if you remember to reverse the drill rotation. And now to tap its partner in crime. So that's my 2 tapped holes. These holes have to fit over a 3/8 dowel pin, but they don't have to be a tight fit on it. In fact, they need to be a bit loose, and that'll make sense when we get further into this. So if 3/8 end mill goes slightly oversized, that's fine. and it has a mate on the other side. And now to do its mate on the other side. I might already have said that. My wife just poked her head around the door, so it doesn't do to ignore wifely summonses. So now I'll clean up and we can do a test fit. So checking to see whether the hole's in the right place. Those are the two dowel pins. I've got O-rings on there, so this can't go down flush against that at this point. And hopefully that will, yep, that's good. You'll see why in due course that it's not essential that those pins are a tight fit, although they are, as it turns out, pretty close, so that's good. Now this thing has to be able to bolt on there. That's a bit tight, why is that? Perhaps the hole isn't cleaned out properly. That might work a bit better for us. Let's try this again. Yeah, that's good. Next operation is to counterbore the four corner holes to accommodate the head. I'm going to use a 14 diameter end mill to a flat bottom hole and go 8.5 millimeters deep. Might slow him down slightly too, to 600. Come out of back gear, that would be good. Be in the right direction, that would also be good. Test one of the bolts in the hole. Nice. Just get a rule to make sure it is actually below the surface. Yep, perfect. 3 more to do. For the second plate, I decided that instead of using this end mill to remove most of that material, I'd use this cutter with cheap, easily replaced inserts. It should be able to hog that off fairly easily and save my end mill for better things. This is, I don't know, 60 diameter, something like that. I'll spin it at 1000 RPM, 5mm depth of cut, see how that works. Well, I seem to manage that without too much trouble. Might finish it off with 2 passes, one at 3 and the last one at 2. That's working pretty well, so I'll do the other 3 corners the same way. So with the 4 corners clipped off, I've mounted it on the fixture and I'll rotate the workpiece around until the cutter makes contact. It's just touched on a couple of the corners, so I'll feed it in 1mm. I have the cutter set for full depth, so we'll see how that goes. Seems to be coping nicely with that. So I think you can see the cut pattern here, and so I'll come in a bit further and we'll be cutting on the full circumference. I'll do one more pass at the same depth of cut of 1mm, but I want to get some coolant or some lubricant on it. So I'll just move the camera out of the way. I'm set up for the final pass now, which will be a 0.5mm depth of cut, and hopefully the chips will fire away from me this time. So that finishes rounding the corners. Now I've got to do chamfering all around the top edge. Don't have a lot of experience with doing this sort of chamfering, but I've just done a test pass with a 0.2 depth of cut, and I want a bigger chamfer than that. I've reset the depth to 0.4 and we'll see what that gives us. Well, that looks pretty good. I don't think it needs to be any bigger than that, so we might just go with that. Well, that was quick and easy. I'll move it over to the vise now, so I can hopefully put a similar chamfer on these four faces. I'm not sure how well that chamfer showed up on the camera round to this side, so I just took another look at it from a different angle, see if it showed up a bit better. So the first edge worked out alright. I've turned the piece around in the vise and I'll do the opposite side now. Sorry, I realised you couldn't see very much in that previous shot, so I'll film another one, moving this way. I'll start off with a 0.2 depth of cut, and if it's looking right we'll do a second pass to get to 0.4. That's looking pretty good. I'm going to call that done. And now I just have to turn it around and do the fourth side. So I'm getting ready now to drill a 4-hole bolt pattern matching this plate into the top surface of the cross slide. These holes will be, the 2 holes at the back can go right through, but the 2 at the front need to be blind because I don't want to come out into the underside of the sliding surface. We spend a bit of time with my mate, that is, positioning this for the optimum. At that location the top slide can stay on and this will have some limited rotation. This will have to come off to get full rotation, but there might be times when that's useful. I want this to finish up on this surface with this plate hard up against that. It's there as an indexing plate. When I drilled the 8mm holes, the drill conveniently made them about 8.1. Most twist drills go slightly oversized. This is an 8mm dowel pin in a collet chuck, and I don't know whether you'll better see this in the camera, but there's a little bit of movement there. That's the movement in the hole I was talking about, and I've got a little bit of movement this way. The side to side isn't important because the exact location of this that way in the X direction isn't important, but it's very important in this direction so that this plate can be up hard against this face. So I believe I've got the dowel pins centred in the hole such that there's an equal amount of movement fore and aft on the screw. I'll drill the hole with a drill in the collet chuck rather than using the 3-jaw Jacobs chuck, just because this will be slightly more accurate, and anything which helps to guarantee that the hole finishes up in the correct place is a good thing to do. To make sure I don't get chips and rubbish falling down in there, I'll just cover that up with a piece of plate, and I think we're about good to mount the drill. I've decided to drill all 4 holes 15 deep, so they will in fact all be blind, but I should be able to get 12mm of thread in each hole. Here we go. Oh, that's all the holes drilled, and now tapping the holes. To make sure I stop short because that's a blind hole. Must be somewhere near the bottom, I think. This is a bottoming tap. Tap me all the way to the bottom, hopefully. That's about it. 3 more to do. So using O-rings on the taps as a depth marker is a trick I should have thought of years ago. I'll certainly be using that in the future. So now for the moment of truth. Hopefully my hole pattern's in the right place. That one goes in. Well, they all start, that's a good thing. And I have got just a small amount of wiggle room on the bolt pattern. So this plate can get pressed up hard to the front face here. I think we can call that a success. So machining the pockets in the underside of the adapter plate to accommodate the heads of the oilers. The oiler is 8mm in diameter nominally, and I thought I'd be able to go a lot less than that because the ball is only a small proportion of that cross section. But the heads of the oilers aren't below the surface, so I need to have a pocket that's a bit bigger than the head of the oiler. I've decided to go with 9mm, but I don't have a 9mm self-drilling end mill. So I've got an 8mm one here. We'll go down a millimetre with that, then swap it out with a 9mm 4-flute end mill to clean the pocket out to the full diameter. So we take these two pockets out to their 9mm diameter now. So hopefully that's two pockets in the right place. So test time. These are the little buggers causing the problem, just sticking up a little bit. Okay, I can feel the thing engaging on the bit that's sticking out there. It looks like we've got a bit of clearance all around. Yep, that's good. So that bolts on there nicely. We'll put the rest of it on. That's the dowel pins going in their holes. Turn this around so you can see what I'm doing. So as you see, this allows it to rotate that way. And this setting here allows the thing to be tilted like that. Anyway, I think that's going to get the job done nicely. So the top slide and tool post are prepared to share the cross slide, to some extent at least, with the milling slide. So that gives a little bit of flexibility. I don't know whether he would ever use it that way. At least the milling slide now can be centred in front of the spindle and be central height-wise as well. So that'll give him the best range of motion of the slide. Okay, well that's it. Job done. Hopefully there's some bits in there that you found interesting. But in any case, thanks for watching, and I look forward to seeing you on the next one. Cheers.